Hello dear students, welcome to TAV Model Public School. In today's subject of science, we will discuss the chapter that is sound. This chapter, it is also there in 8th standard and 9th standard. So we will collectively see what exactly do you mean by sound in this video. So what exactly is sound? So the answer, if someone asks you what is sound, your answer would be it is the form of energy. First and the foremost answer would be it is the form of energy from which enable us to hear. It produces sensation in our ears from which we can hear. So sound is a form of energy which produces sensation. With that sensation we can hear. Second important point regarding sound is sound travel in the form of wave. We will see what exactly this wave in the coming slide, and it always requires material for propagation. Material for propagation means it requires solid, liquid and gaseous. It always requires a medium, which means it requires material for propagation. Here it is also written sound cannot be produced without energy. You might have studied in previous chapter regarding law of conservation of energy. So sound, it is related to energy. Since I am saying sound, it is the form of energy and it is based on the law of conservation of energy. So what exactly do you mean by law of conservation of energy? Energy can neither be created nor destroyed. It is always converted from one form to the other form. So sound, which means sound cannot be created by its own. There has to be some disturbance, then only sound would be created. And it cannot be even destroyed. It is based on law of conservation of energy. If we ignore the factors like frictions and all, then simple definition of sound would be it is the form of energy which enable us to hear. It travels in the form of wave and it always requires material for propagation. It cannot be produced by its own and it cannot be even destroyed. So these are certain things which you have to remember about sound. It requires medium, it is the form of energy. Now let us see how sounds are produced. Sounds are produced by vibrating bodies. Whatever object or whatever bodies which vibrates, it produces sounds. The object which is not vibrating won't create a sound. The object which vibrates, it produces a sound. So what do you mean by the word vibration? Vibration, if the object moves backward and forward, we say that the object vibrates. If the object is doing motion of to and fro, that motion is a vibration. So it is written over here, if the object moves backward and forward, the object vibrates. I hope you have understood the mechanism of vibration. It is simply a movement which involves back and forth movement. Now, the other question arises, how sound is produced by humans? Earlier we have said that, earlier I told that sound requires object from which it can vibrate. So in human also we have certain things which is known as vocal cord. Since vocal cord vibrates, then only human produces sound. So when we speak, vocal cord in our mouth vibrates and sound is produced by humans. So how sound is produced by humans? Sound is produced by humans with the help of vocal cord. If there is no vocal cord, we won't be able to produce. As you can see in this picture, vocal cords is over here. Here, this vocal cord is open vocal cord and this one is closed. The open portion over here, this is trachea. And this is trachea over here. This is trachea. So this opening and closing of vocal cord produces sound in our mouth. And from mouth, it travels to different part of our buccal cavity like teeth and so on. And teeth, tongue, and collectively it produces sound, and from our mouth it travels into the air and then it travels and then a person is able to hear. Now let us see sound produced by an instrument which is known as tuning fork. Tuning fork look like this. This is a tuning fork which look like this. You might have observed this tuning fork in laboratories and all. As this tuning fork vibrates, it produces disturbance in the atmosphere. And this, as you know, that atmosphere contains different amount of atmosphere contains different densities. Hence, here the density of atmosphere is different, and here the density of atmosphere is different. The particles which is residing in the atmosphere gets vibrated, and this particle pushes the other particle, and this particle pushes the other particle, and so on. Since the particle in this area pushes the other particle, sound is traveling in the atmosphere. So this area where the particles are highly dense are known as compression. This area where particles from this tuning forks, particles starts to hit each other in to and fro motion. One particle, if suppose one particle is residing over here, that particle will push other particle and will return back to its position. The other particle will get some momentum, it pushes the other particle and it will come back. In this way, the particle pushes each other, and then a sound is heard by an individual. So where the particles are highly dense, so that particle area is known as compression, and it is highly dense. Same when the particle return back to its original position, there is less density over here, less dense. So this area it is rarefaction. Here low pressure and density is created between particles. Now, how sound travels? As I told earlier, sound always requires medium to travel. This medium can be solid, liquid and gaseous. Sound travel fastest in solid medium, then at liquid, and then in gaseous form. If I consider two situations, this person, I'm naming this person as A and this as person B. Now let us see how sound is traveled. If suppose this person says hello and this person would hear that hello. Let's see how exactly it happens. If this person says hello, since it is happening in the presence of air, so the hello disturbance will be created in the form of wave. This sort of wave would be there in the atmosphere. The particles which is there in the atmosphere will push each other in to and fro motion in this direction, as a result of which a wave would be created. Where the particles are highly dense, that area is known as compression, and since as you can see the particles over here are closely compact, this one wave is there, after certain interval another wave is there, third wave is there, and so on. If you observe this area is highly dense, and as you can see this one, there is a gap between two or more waves. Certain number of gap is there, here also certain gap is there. So this area is rarefaction, which means it has low pressure and density. Here it has high pressure density, low pressure density, again high pressure density, here it is low pressure density, again high pressure density. In this way the word hello is traveling, and then this person would be able to hear that word hello. So this area is again high pressure density, whereas this area it is low pressure density, known as rarefaction. Now, sounds travel like a wave. You might have studied something about wave. If you take an example of, if you pour stone in still water, you will observe a ripple sort of thing. That ripple is nothing but a wave. That wave, what exactly that wave is? It is the movement or disturbance through a medium due to a particle motion of the particle about its mean position. As you can see in this picture, two-person is residing over here. This person gives a jerk to this rope. This rope will travel in the form of wave, and this jerk would be felt by this person, and vice versa, and so on. So in this process, a wave is being created, and this line is indicating the mean position of wave. Slowly and steadily in higher classes, you will come to know about what exactly the mean position of wave are. For a time being, you might simply have to remember this is a wave. Wave looks like this. To be more precise, this is sinusoidal waves, a wave sort of thing. There are again different types of wave you will understand in 11th and 12th standard. Now, sounds travel like a wave, and sound waves are mechanical waves. Now, waves are basically of two types, mechanical waves and electromagnetic waves. What is the difference between mechanical waves and electromagnetic waves? Mechanical waves are those waves which requires medium, which means it requires solid, liquid or gaseous. That wave is termed as mechanical waves, whereas electromagnetic waves are those waves which do not require any medium. So the perfect example of electromagnetic waves are light waves, UV rays, X-rays, gamma rays, infrared, and so on. You might have observed that sun rays consist of 7 types of radiation. That radiation is nothing but electromagnetic radiation, which includes visible rays, UV rays, infrared rays, gamma rays, X-rays, and so on. So that is nothing but electromagnetic waves, which means which does not require any medium. Here we are not concerned about this electromagnetic waves. We will see this in the chapter of light. But here we are concerned with mechanical waves. Now mechanical waves are of two types, longitudinal waves and transverse waves. So we will see in next slide what is longitudinal waves and what are transverse waves. And the behavior of electromagnetic waves is transverse. That's why I've drawn an arrow so that indicates it is traveling in the form of transverse wave. We will see what is longitudinal and transverse wave in next slide. In this slide, it is simply waves are of two types, mechanical waves and electromagnetic waves. It requires medium, it does not require medium. Mechanical waves are of two types, longitudinal and transverse. That's it. Now, let us see what are transverse wave and longitudinal waves. First we will see something about transverse wave, then we will proceed with longitudinal wave. Now suppose this dot portion is a particle. Particle travel in perpendicular direction of wave. Now suppose this is a wave. Particle travel in perpendicular direction means this is a particle. Particle movement would be upside down. Particle will move in this particular manner, in which the particle will create perpendicular direction. This particle would be perpendicular to the wave. You can simply correlate this. Particle is moving in this direction and direction of wave is this direction. So which means both direction of wave and particle motion are in perpendicular direction, which makes direction of particle and wave are creating 90-degree angle, which means this sort of thing is a transverse wave. Transverse wave, it can travel only in solid and liquid. Yes, transverse wave can only travel in solid and liquid. It cannot travel in gaseous or air. These waves travel in the form of crest and trough. So this portion, which is highly dense, it is known as crest, whereas this portion, it is trough. Here this portion indicates it is less dense and this portion indicates it is highly dense. Again, this is one crest, this is one crest, this is trough, this is another trough, this portion is another trough. So this portion in terms of transverse wave, I will always say it is crest, and this portion it is trough. So as I told earlier, the particle will vibrate upside down in this manner, as you can see in this animation. Particle will move upside down in the direction of wave, perpendicular to the direction of wave. Now let us see what is longitudinal wave. Longitudinal waves means particle travel to and fro along the direction of wave. Now particle will move in this direction. Earlier in this case particle was moving upside down, which is perpendicular to the wave. Now, what are longitudinal waves? Longitudinal waves travel to and fro in along the direction of wave, which means particle is traveling in this direction. Here it was traveling upside down, here it is traveling in this direction. So, which means particle direction are parallel to the wave direction. Here in this case, particle direction was perpendicular to the wave direction. Here in longitudinal wave, particle direction are parallel to the wave direction, which means particle move to and fro along the direction of wave. Particle will move in this direction and wave will also move in this direction. And longitudinal waves, it can travel in solid, liquid and gaseous. It can travel in all three forms. These waves travel in the form of compression and rarefaction. Here in this case, I was using the terminology crest and trough in order to indicate transverse wave. For longitudinal wave, I will use the terminology. It's the same, highly dense area I will termed as compression, whereas less dense area I will termed as rarefaction. In longitudinal waves, I am simply naming the term, that is compression. This area is compression and this area is rarefaction. Whereas in transverse wave, this area was crest and this area was trough. Now, as you can see in this animation, particle is moving in this direction along the direction of wave. Here, as you can see over here, particle is traveling in this direction. So this area, it is compression, whereas this area, it is rarefaction. This is highly dense, this is less dense. I hope you have understood the concept of sound. Thank you and have a nice day.